I already did a presentation for those who were here like 2 years ago. So today's presentation is going to be about something we did last week. We actually open sourced our Liquidshop scripts. So yeah, this presentation is about this repository we put online. So the target of the audience of this presentation should be people that are starting with Liquidsoap maybe, or just want to see an example, a working example. And our main focus is on the monitoring tools we put around Liquidsoap, and the way we organize the code, and how it's working in general manner. So it's not going to be a very deep Liquidsoap syntax presentation. I'm just going to share you my consideration of someone working as a DevOps or infrastructure engineer. So yeah, I'm not an audio specialist. I mean, not on the work side. And yeah, this presentation is more going to be about a portable Docker infrastructure for making live streams. All right. So first of all, I'm gonna do a little reminder of our context, because we already present everything 2 years ago, and you can find the presentation again. There is also a super interesting presentation that Max did at FOSDEM in 2020. So I'm going to try to not repeat everything. The main focus is here. So the requirement for production-ready Liquidsoap-based streaming platform. I'm going to show a demo stack and the scripts we put online. So about the context, Radio France is a French public media focused on information, education, entertainment, and culture. There's a lot of journalists, a lot of reporters. We do live events. We have a lot of listeners. We won one of the top radio station streamer in France, top radio group. We broadcast using FM, DAB+, and internet. We are 200 co-workers handling the presence of Radio France on the internet. So it's just a small part of Radio France. And we love open source. So that's why we are releasing things online on stuff like this. Our radiophonic activity is split into different kind of channels. We have 26 web radios streaming all day. 45 local channels. It's for regional content. Each region of France has its channel, and yeah, a lot of radios. And we also have the biggest 7 national channels like France Inter, France Culture. A lot of people in France listen to them on FM, and we have a lot of listeners online too. And we also provide some on-demand channels. It's like radios we put online for specific needs, and we have like 3 of them. So in total, it's like 80 radios. Our Liquidsoap usage is actually very basic. At in the team we work, we don't have to manipulate audio. So the only thing we do is taking audio from Radio France and just stream it online and nothing else. So the pipeline we built with Liquidsoap is just taking multiple inputs, perform source selection with auto fallback. We encode the audio in the codec we need to stream, and we stream it using HLS and icecast. So there is no playlist, no audio transition or advanced processing. We don't do normalization there. There are people at Radio France, it's their job to know audio and to be good with it. So at the team we work, it's just, take audio and put it online. And we kept it simple. So we just took one process of one Liquidsoap process per stream. I wrote at least because we have multiple environments. And the target is to keep the latency as low as possible. So yeah, most of the latency is introduced by the protocols like HLS and icecast. So we try to keep everything real time. So just to sum up the stack that's needed to put online a stream, I did this little graphic to summarize it. So multiple inputs going to a single Liquidsoap process. Liquidsoap produces audio to icecast and nginx to serve HLS. And we have a Prometheus monitoring with Grafana and alertmanager for dashboarding and alerts. So this is a very basic diagram of what I'm going to show in details today. And let's go. So when you're building a production environment, the major focus is achieving input resilience. For example, if you have to stream audio content coming from a studio and your infrastructure is not located at the same place as a studio, you need a way to bring the audio from the studio in a resilient manner to the Liquidsoap process. So a good use of the fallback operator is to have multiple inputs that contain the same audio but coming from different paths. So this is what we did. We have a self-switching input mechanism that will consume audio sources in order. And if one source is failing, it will fall back to the other one, the next one. We also have to protect stream continuity at all costs. Because if your Liquidsoap is not receiving any inputs, it should have a mechanism, a fallback mechanism to send audio to the client so they don't get disconnected. We are just using a safe blank source, but you can use a audio loop or something else, and it's really easy to achieve. So this is a multipath inputs I was talking about. At Radio France, we use like 7 inputs for each station we broadcast. This is much more detailed in previous presentation, so today I'm going to go very fast on this. But yeah, each station, each Liquidsoap process has all these inputs. It's a lot of audio streams, but it's a good way for us to achieve resilience. So we have the audio coming from the studios, and we also have a way to override these audio sources with live content coming from somewhere else dynamically. We're using something called auto fallback. It's a variable we created to ask the fallback loop to use or automatically some sorts of inputs, but we can also manually fall back to another one with an HTTP API I'm going to show later. Other important point for a production environment, it's a good thing to have multiple Liquidsoap processes or instances per station you stream. This way you can achieve script updates, you can do errors, and it's okay. Liquidsoap could crash, and you have a fallback mechanism that way. And it's a good way to perform updates, upgrades, and things like that. So that's an important part of implementation. And it's a good way to have multiple streaming servers, of course, but you all know it. Like master relay icecast architecture with load balancing, for example. Or for HLS, we use CDN, content delivery networks, for the static audio content. So we can protect our infrastructure and handle the many visitors we have. For production environment, you also need good observability on Liquidsoap. You need to be able to say, is my Liquidsoap running? Can I receive the audio sources well? Can they be decoded? Is my Liquidsoap producing audio? You should have logs. You should have network metrics too, saying the bandwidth usage, or maybe discovering your jitter latency because it can impact the audio. You should have system metrics. The Liquidsoap pipeline metrics, like if you do buffers, you want to see how your buffers is behaving, or maybe you want to see the clock latency, clock drift, something like that. And finally, it's a good thing to have also audio metrics like LUFS levels, an estimation of the average level of audio you're streaming. Or maybe is the audio totally blank? You also want to have tools for operators for you. So in Liquidsoap, you have the Harbor HTTP API that is very useful for this. You can get information from it, but you can also perform action, like, for example, live source selection. So this is what we did here. We use Harbor to expose two routes. This one is just for getting information. So we have a readiness, returning just HTTP 200 when it's working. And we also have a live source route that tells us which live source we are using in the auto switch loop. So this is how you write a simple HTTP handler in Liquidsoap. Maybe you can find it in the documentation, but I just put it here the way we implemented it. So it's very easy to write. It's working perfectly. So for the live source, you can use metadata in your audio streams to get information. And you can perform like blank detection and tag your source with metadata and get it afterwards in the get live source method here. So this is all the example we put in the GitHub repository, and you can find it later. And obviously you can post messages to the HTTP API. And post is a good way to perform actions like switching input source. And this is what we did here. I'm going to go very fast on the code because I really want to show you the demo stack. So I'm going to go faster. So to finish, a standard production environment should contain alerts, so a way to notify you something is wrong. And you should also have runbooks to give a way to behave when something is definitely wrong, so you don't get lost. I'm going to add some points because at Radio France we're in the cloud, and as a DevOps, we have some recommendation of the way to implement something in production. We're speaking about cloud native environment because there are some kind of reflexes, like things we do all the time, and we can achieve this with Liquidsoap too. So your service should work, and your stack in general manner should work without human interaction. So we achieved this with auto fallback loop I showed previously, but it should also maybe be something like when your liquid soap is starting, it should work, and it should work by default at the very beginning of the process. You don't want to perform manual actions to, switch sources or enable something when when the process starts. And maybe you want to auto restart the process when it's failing. Of course, notifying you, but you don't want to be in front of your server all the time and nurturing it like a baby. You just want it to work all the time, and if it fails, you want it to restart. To build a cloud native environment, you may want to use classic and standard open source tools for monitoring. For example, Prometheus for the metrics. It's a server that allows to, get metrics each time you call an HTTP API. It can be metrics about your latency, everything I talked earlier about. You may want to parse your logs, so maybe the formatting of your logs is important, and Liquidsoap is doing well, as Romain talked about earlier, with colors now. You may want a grafana dashboard to make a visual representation of your metrics. And you could use alertmanager to automatically send you message, for example, on Discord, on Slack, each time something is going wrong. So I give an example of Prometheus. As I said, Prometheus is just a standard HTTP server, and each time the Prometheus server is going to ask Liquidsoap, "Hey, how are you doing?" Liquidsoap is going to tell, "Okay, I've got those metrics and their value are this at the moment." And each time you perform a request, the values are going to be updated. So this is what we achieve. And I gave you an example here for the audio levels. So we just create, first of all, we create a Prometheus server in the Liquidsoap script, listening on port 6001. Then you can create a metric, give it a name, so it's just a method. Creating a gauge, it's the kind of metrics you want to create. You give it a name, a description, and maybe labels. For example, the name of your radio or something like this. You create the metric instance in your script, and maybe attach it to the radio source you want to, expose. And during the main loop processing, you can use useful operators like lufs, which is going to enrich the source with audio level average. Here I'm using 5 seconds window, but it's just going to add metadata to the source you're using. And finally, you can expose the value. So every 5 seconds, you update the metric, so it takes the lufs value of the source. And that way, each time you put a request on the Prometheus server, you will get this value updated every 5 seconds. So that's it for the recommendation about Liquidsoap itself. And maybe I can add some recommendation about the organization of your scripts. Thanks to Romain, we found a good way to split our Liquidsoap scripts in parts. Each of the file has a specific part of the full project. For example, one of them is handling all the Prometheus metrics, but we also have a specific file for HLS output, the HTTP API, and so on. And this is very easy to achieve. You just have to use include in the beginning of your first script, and you can include every other parts. And something interesting we found is you can write generic scripts for all your needs and do the specification at the last minute with an additional file. And that's how we work. So the script folder in our repository contains something anonymous. It's all of our radio that works the same. And we just add some variables like names, ports, and audio sources in a supplementary file. In the script, you'll find an example of this syntax, and I'll show it later. So this is just the command you can pass to add the configuration to your main script. And this is looking like something we do in big infrastructure management called industrialization. And it's something you'll find again in Ansible, Chef, or Puppet. So it's a template folder and something like an inventory doing the things you need. And sometimes you have too many variables to specify in your inventory. For example, as I said earlier, at Radio France, we have 77 radios in production. So we need to generate those files. And you can use something like Jinjador or JSONet or anything else, templating language, to generate it. I'm just going to check how. Oh, I'm very bad on the clock. Sorry. I'm going to go very fast. It's a good way to have a versioning of your scripts. So using a script folder, it's very easy to create versions and perform updates. And you can use Docker in production. Docker is very good when it's not stateful applications, but when you're going in a stateful environment, it's not so good. But it's still doable, and we did it in the demo script. So maybe you want to think twice about using Docker in production for your Liquidsoap, but for testing, it's super awesome. And it brings you a lot of interesting features like reproducibility, sorry, and upgrade rollback facilitation. So I'm just going to show you the whole architecture of the script we open source. You'll find it in the README of the repository. And now I'm just going to go very fast on the demo. I don't have the time to show you the end of the presentation, but let's go to the demo itself speaking. So I just cloned the repository. It comes with a makefile. It's a good way to manipulate the Docker compose we provided. So I'm just going to start the stack with make start. I already did it earlier, so it's just starting instantaneously. We have a test container that will stop with return code 0 if your syntax is okay. And you already see the logs of the Liquidsoap stack. Once you did it, you can, for example, show the URLs of the stack. So if you want to listen, you can just copy paste some URLs. So in this demo stack, I'm streaming Pnode, modular station, and Datafruits radio in a main live stream. And I'm just remixing it and re-encoding with MP3 and HLS. So I can just press play. I'm going to put the sound on. Just press play, and you can perform operation like switching the live source. So right now I'm switching to data fruits. I think it worked. You can see your current live source with this. I'm using override color 1, which is data fruits. And you can go back to main source. Okay, stop this. Also interesting feature, we have the Prometheus API exposed. So you can perform research of metrics. So right now the audio is not blank. You also have grafana dashboard we provided, showing you the readiness of the live source, the LUF-S levels, and the current live source. You saw I did a small live source change here, so you can see it in the dashboard here. We have buffers, things like this. Another LUF-S level that can scale with your Liquidsoap scripts, meaning if you have multiple radios on Liquidsoap process, you can monitor everything in real time in a single dashboard. So this is not the stack, this is our production actually. And I'm showing you Radio France live stream in real time. And that's it. Okay, I've just got 1 or 2 minutes to conclude. So
yes, take your time to conclude. We are not 1 minute. We are not 1 minute short. Or
okay.
It's not a big deal.
So you'll find everything you need in the README, I think. If you don't, feel free to ask me anything you want. Maybe open an issue or just contact us. We'll do our best to answer you. We have some room from improvement. For example, I'm not super happy with the name we named the variable, so I hope you won't struggle too much if you want to use it. Maybe we can split files a bit, improve the file splitting a bit more, use more templating. We have known issues, especially with buffers. We are trying to address with Romain, and I can't wait to see the new clock implementation in the future release. So you may experience some bugs with it. Yeah, I plan to introduce new Grafana dashboards in the repository so you can easily use it. We are still missing a GitHub CI for linting your pull request if you want to do any. We did it earlier on GitLab, so it was working, but since we migrated to GitHub last week, I need to rewrite those files. And maybe I should add alerts and CAdvisor example in the Docker Compose. And add a changelog automation. And that's it. So yeah, something I didn't show. If you want to clean everything after using your stack, you can just run make clean, and it will stop all the containers and clean any volumes that has been created, leaving your computer free of anything. That's it.
Thank you.
Thank you very much. It was a very cool presentation. So does anyone has questions? So we had again many questions in the chat. Maybe someone wants to raise them. We'll take the presentation to upload the new slide, but you can continue discussing. Who wants to start? Gilou, I see your face, so maybe it means that you
I have like 3 questions and some feedback as well. There are some interesting questions in the chat, but mostly they were answered along the way. I had one question about your multiple liquid soap inputs. Do you care, or do you have a way to keep them in sync in case you have to switch? How do you do that?
That's a very good question, actually. We don't use SMPTE or any signalization in the sound. So right now it's just audible when we switch sources. And that's a problem because we have currently some buffer issues making Liquidsoap to consume audio faster than the source is producing. It can
hence,
also, and it can.
Hence, you waiting for the clock. The clockwork, maybe, I don't know.
Yeah, that's it. You understood it. And audit listeners of our stream can hear a glitch, audio coming back in time and faster afterwards. And it's something I really want to mitigate in the next months. So I work a bit about it, but right now I don't have any in-hand solution.
So that I'm not the only one taking the floor. Luigi asked you, and I think I can answer, but I'm not going to let you answer. If nginx for HLS could be replaced by Apache, I would assume you can use whatever you want. It doesn't matter.
Yeah.
It's static.
We don't use nginx at all in our production environment. The demo stack I showed, I put it with nginx for convenience, but at Radio France, we just implemented our own web server to create the HLS playlist. That way we can handle query strings and, time shift you want to listen to audio back in time. So it can be anything you want. Any web server will do the job.
And it's interesting what you said about keeping multiple Liquidsoap feeds in sync, because that's a discussion we had with Sam and Romain at FOSDEM. Sam else doesn't seem to remember it, but that was maybe after the beers. So, but it's interesting because that's something radio automation software is really conscious about, because you need to make sure that it's as less glitchy as possible for the users when things go bad. And I have another question regarding this. You seem to be using SRT listeners for the feeds. How good are they to actually deal by themselves on the bad connection situations? Would you say it's just a fallback from Liquidsoap, or do SRT actually manage as an input to adapt the bitrate so that the connection doesn't fail?
Okay. I never experienced with multi-source SRT, because in one SRT tunnel you can have multiple input sources, and it's something very new. I never tried, but just to take audio from one point to another.
Oh, you just do SRT on a fixed bitrate. You don't do adaptive SRT there.
I was not talking about the bitrate. I was talking about multi-source SRT, like hub and spoke, distribution.
That's okay. Wait, I was wondering if you were actually using the SRT part of the protocol that allows you to renegotiate in real time if the thing is bad, but it seems you're not using it. So
well, no, we are just. It's a way for us to cross network. I mean, if I could do something else, I would do something else. It's the easiest way we found to put audio to the cloud, because in the cloud there is no multicast support.
Yeah.
And it just doesn't work. But I think we would like to experiment more about SRT capabilities to
feed.
To handle disruption in source, because right now the SRT tunnel will just cut, and we have the auto fallback mechanism in Liquidsoap, but I know SRT can do better, and we're